All right, here are solutions to quiz 1 for Math 251. We're given this function, f of x equals x squared plus 1. And first we're asked to find the slope of the secant line to f to this function from 2 to 3, two different x values here. To figure out the slope of the secant line, we want to do the change in the y values divided by the change in the x values. So really we need four things. We need to know x1, y1, x2, y2. Fortunately, x1 is already given to us, as is x2. If we want to figure out, maybe I'll switch colors, y1 is just f of x1, and x1 is 2. So all we got to do is figure out what is f of 2. Well, f of x is x squared plus 1, so f of 2 would be 2 squared plus 1, which is 4 plus 1, 5. And similarly, y2 is just going to be f of x2, which is 3. So we need to figure out f of 3. F of x, again, is x squared plus 1. So f of 3 is going to be 3 squared plus 1. 9 plus 1, or 10. So now, with these four pieces of information here, we have enough, we have all the numbers we need to figure out the slope of the secant line. y2 is 10. y1 we got is 5. x2 is 3. And x1 is 2. So we get 5 over 1, in other words, 5. So the slope of the secant line from 2 to 3 is 5. There you go. Find the slope of the secant line from 2 to 2.1. Okay, we got x1, we got x2. We already know y1 from above, so all we need to know is y2. Right, y1 is still 5 because x1 is still 2. But for y2, we'll have to figure out what is f of 2.1. Fortunately, I gave you a little bit of help here. To figure out f of 2.1, f of x is x squared plus 1. So this is 2.1 squared plus 1. Without the help of a calculator on a test, that's a little bit annoying to figure out, but I told you that 2.1 squared is 4.41. So 4.41 plus 1 is 5.41. And now I can do this same calculation here and say the slope is the change in the y values, y2 minus y1 over x2 minus x1, over the change in the x values. So it's 5.41 y2 minus y1, which is still 5, over x2, given here is 2.1, minus x1, which is 2. And if you do this math, you get what? 5.41 minus 5 is just 0.41. And 2.1 minus 2 is just 0.1. And you can simplify this fraction. If you multiply the top and the bottom by 10, you'll get 4.1 over 1. In other words, you will get that the slope of the secant line from 2 to 2.1 is 4.1. So when one of our x values is 2 and the other one's 3, we get a slope of 5. But when we leave that one at the first one at 2 and bring the second one a lot closer, bring it to 2.1, we get to 4.1. Maybe this and the practice from your homework is enough for you to be able to take a guess and say, well, the secant line, if we took kind of this idea of a limit, if we let this second x value get really, really close to this one, instead of 2.1, it was 2.00001. We probably get a value here pretty close to 4. So when you're estimating the slope of the tangent line to f at x equals 2, I don't know what you can write. It's 4. Looks like we're getting close to 4, so the answer is 4. Maybe you can figure out a way to show work there, but I can't. Just write the answer. There it is. You're done. Suppose the function, okay, so this is trying to put this into context. We're saying this thing up here, it's going to give me the distance that I am from my office x hours after our class ends. So basically what it's trying to say is if your function gives you distance, what does the secant line mean and what does the tangent line mean? So this is really just, if you remember, we went over this, that the secant line gives you the average speed, the average velocity. So if we interpreted our answer to part A, in part A we found the slope of the secant line from 2 to 3. What that would tell us is that maybe my average speed from 2 hours after class to 3 hours after class. So during that time period, my average speed was 5 miles per hour. You could leave it just as 5, or you could put in mph, because I did say miles and hours here. I don't really care. And then for 2 here, it's kind of the same idea, except now we're interpreting this one here, this 4. Now we're talking about the tangent line. Secant line gives you average speed. Tangent line gives you instantaneous speed. So my just speed, you could write instantaneous if you want. You don't have to. Instantaneous. I don't know if that's spelled right, but I really don't care. My instantaneous speed 2 hours after class is 4. And if you wanted miles per hour. So there you go. That's the end of the first problem. Figuring out the slope of the secant line and the tangent line, and then kind of interpreting them. All right, second one, we're given this graph, this kind of crazy looking graph, and asked to evaluate a bunch of things, a bunch of limits. So this one, man, that's hard to see. The limit as x approaches 0 from the positive side of this function. So x equals 0 right here on our y-axis. But what we want to know is, what is the height of this crazy looking graph if we get really, really close to 0, so we're somewhere in here, but we're coming from the right-hand side, from the positive side. So it looks to me like it's, I don't know, a little bit less than 3, maybe 2.9. Maybe I'll say about 2.9. If you said 3, that's fine. If you said 2.8, whatever, I don't care. Just showing that you know what we're going for here. It looks like we're getting close to wherever this, what I'm looking for is, what is the height of this circle right here? It looks to me like about 2.9, but whatever. What about if we're approaching -1? So now we're talking about over here, but we're coming from the left-hand side. Well, then your height is going to be whatever the height of this purple circle here is. Looks like it's right on the line to me, so I'd say that's about 3. Maybe we don't need about there. I'm just going to put 3. What is this height? Looks like it's about 3 to me. All right, what about if we're approaching 1, but now from the negative side? So here's 1. I'm coming at it from the left. So I'm on this line right here. Looks like my height gets really close to 1. So I'm going to say that's 1 right there. Now it says, okay, what's the limit as you approach 1? So that same point, but now it doesn't tell me if I'm coming from the left or the right-hand side. So what you have to do is say, all right, from the left-hand side, we figured out the height was 1. But if you're coming from the right, we'd also get that same height, that the height is equal to 1. So what we'd get is that, well, the answer would be 1. We could, if you really wanted, you could say the limit as x approaches 1 of g of x, let's see, from the negative side equals 1. And the limit as x approaches 1 from the positive side of g of x equals 1. So this limit as x approaches 1, when we don't specify what side, it's equal to 1, because these are the same. Now we're talking about, what if it were -1? Well, let's first figure out what would happen if I came at -1 from the negative side. Then we'll figure out what happens if I come at -1 from the positive side. And you don't need to show all this work. If you just put this, you're fine. I'm just trying to explain how we got these answers. So let's see, -1, if I'm coming from the negative side, it looks like my height is about 3. I guess we already did that in part B. But if I'm coming from the positive side, now I'm down on this line here. Looks like my height is, I don't know, 0.8 or something. So what that means, because we got 2 different numbers there, that means that this limit doesn't exist. So there you go. When you get different limits coming from the different directions, that tells you that the limit does not exist. So that's the answer here to part E, and that is the end of this quiz.